I'm going to start with this skinny lavender area, which will correspond with isovolumetric contraction. If we start up here, we can see that this is the very end of the QRS complex. Remember that the QRS complex represents the depolarization of the ventricles. The electrical event will be followed by the mechanical event. So QRS will be the electrical event, and you can see if you go down to the next panel here, it's the very beginning of ventricular systole. If we follow this down to the pressure portion of this graph, we can see that not much is changing with the aortic pressure, but what we can see here is that the pressure, the blue line, represents the pressure in the left ventricle. That is increasing quite a bit here. Okay. If we follow this down to the heart sounds, we can hear the lub at this time of the lub dub, because the lub represents the sound of the blood hitting the AV valve after it's closed. The volume does not change, and that's going to correspond with anything that says isovolumetric, because that means it's the same volume. Okay, this is the isovolumetric contraction, and what this is telling us is that we've begun to contract, but the pressure in the ventricle has not exceeded the pressure in the aorta yet. So we have not forced blood out through the aorta. If we go up to the next segment, we can see that this is that segment where we have no change in voltage, and then we're going to have the repolarization, the T wave, the repolarization of the ventricles. If we follow this down, we can see that this corresponds with the end of ventricular contraction or ventricular systole. If we follow this down to the pressure portion of the graph, we can see that there's a spike in the pressure of both the ventricle and the left ventricle and the aorta. So the left ventricle has finally overcome the pressure of the aorta, and blood is being forced out of the left ventricle into the aorta. That's what's causing this steep increase in pressure in both the red and the blue line. Okay, eventually they're going to begin to relax during this phase. Notice also that we see a little bit of an increase in pressure in the aorta. Pardon me, the green line is the atria, because the atria are filling here. They're relaxed here and they're filling. Okay, notice that in the volume portion of the graph, we've got this steep decline in the volume. That's because we're ejecting this volume from the left ventricle out into the aorta. Okay, and this corresponds with ventricular ejection. Okay, if we head up to the next phase, this kind of small portion of the blue here, okay, that's the tail end of the ventricular repolarization, so the electrical event, then that's going to correspond with the very beginning portion of relaxation of the ventricle, the mechanical event. If we look here at what's happening with the blue line, we can see that the ventricle is beginning to relax here, okay? And we see that the aorta has this spike in pressure. That's the dicrotic notch. That represents that recoil. So when the ventricle overcame the pressure in the aorta and forced all of that volume out, the aorta had to expand. That elastic tissue had to expand to accommodate that volume. Because it's elastic, it's going to go back to its original shape. It's going to recoil, and that's going to provide the pressure that we need to keep the blood flowing away from the heart to the rest of the body. Okay, and we've got the ventricle relaxing. Okay, this is going to correspond with that second sound, the dub, because as the ventricle relaxes, remember, we're going to have a little bit of blood that goes backward in the aortic arch back onto those semilunar valves. Okay, and we're going to get the pressure associated, the turbulence associated with that is what we're going to hear. If we follow this down, we can see that on the volume portion of the graph, there's no change. So this is going to be another one of those isovolumetric pieces. So this case, the ventricle's relaxing. So this is going to be isovolumetric relaxation. If we head back up here, we've got this portion between the end of the T wave and the beginning of the P wave, and that's going to correspond with the relaxation of the ventricles. Okay, we can see that in this graph, okay, the aortic pressures return to normal. If we look at this graph, the blue line now is below the green line. The green line is atrial pressure. The blue line is ventricular pressure. And that's what we want to happen if we want blood to passively move from high pressure to low pressure. We want it to move from the atria to the ventricles. So the ventricle must have lower pressure than the atria. Okay, and we can see on the volume portion of the graph here that we've got an increase in volume, which corresponds with what we would say passive ventricular filling. Okay, at the tail end of this blue section, we've got the beginning of the electrical event of the P wave. Okay, that will be followed by the mechanical event of atrial systole. Okay, and that will correspond with atrial contraction, which will be that atrial kick, squeezing that last little bit of volume here on the volume graph, that 15 to 20% of volume from the atria into the ventricles. And you can see on the pressure graph here that the green line increases, the blue line increases, and actually when we get to the tail end of this area, we're going to see that the AV valves close there, because now we're going to get ready for the isovolumetric contraction phase.